Okay, good morning, everyone.
Morning,
Morning, sir.
Morning.
Good morning.
Okay, so today we're gonna continue our notes on our study of waves. Right, so we end of class last time by taking a look at wave parameters, and what we look at is the amplitude of a wave. Right, so we could just take a look at the amplitude. All right, sorry about that. Right, so what we want to look at next is what we call the phase of a wave. Right, the phase of a wave. Um, the next point is a phase of a wave. Right, and phase, this is what is defined as its points in a progressive wave remember we defined last time what a progressive wave was, and if you missed that, you can look at the previous video. Right, so points in a progressive waves are in phase. Now what does phase mean? Right, anybody have a idea what phase is? Anybody want to guess?
They're the same length of earth on the wave.
Okay, I can take that. Right, so they are in phase if the distance between the points, if the distance between the points are equal, well, is equal, I should say, because we are talking about the distance, is equal to the whole number of wavelengths. All right, so you'll see just now what a wavelength is. Right, a whole number of wavelengths. And we'll come back and define what we mean by this. Right, so right, what about if they are out of phase? So points are out of phase if they have what? So points are out of phase if they have if their distance, I should write, if their distance is equal to any odd multiple of a half wavelength. So like a half of a wavelength, 3/2 of a wavelength, or 1.5 of a wavelength, 5/2 of a wavelength, and so on. So right, so it's like an odd, so it's like an odd number over 2 wavelength. Right, and again we would see what these things mean. So let's take a look at an example. So suppose we have a wave like this. right? Something like that. And I look at the points. So this is my point A, and let's use a different color. So this is my point A. This is my point B. Right, let's put B up here. This is my point C. A point C, a point D, a point E, F, and so on, right? So we would come back and try to see which points are in phase and out of phase when we define what a wavelength is. Right, so let's define wavelength now. Right, so let's define what a wavelength is. Wavelength. Right, now this says exactly what it is. It's the wavelength, right? So a wavelength, or the wavelength, is the distance between successive points. Right, successive points. Now, I know that the textbook may say the distance between successive points that are in phase, right? But if we use the wavelength to define phase, and we're using the phase to define wavelength, then we're using what we call circular reasoning. So I think this definition right here is sufficient. We don't need to say that they have to be in phase, because this one kind of says it already. So if we look at a wave, and we start here and we go here, this is our wave that we're looking at. The distance from this point to this point is one wavelength. All right, so if I was to continue the wave, let's see. All right, the distance from this point to this point is also a wavelength. So that this distance here is a wavelength. Right? This distance to this distance is a wavelength. This distance right here is a half of wavelength. So from here to here is a half wavelength. Right? From this distance here to here is a half of wavelength as well, because we are half away through the wave. Right? I think I'll understand what wavelength is, or how to find a wavelength using a graph. It's
Yes,
just
sir.
successive points.
Yes,
Right, so this one and this one are in is a wavelength. From here to here is only a half of a wavelength. Right, from here to here is only a half of a wavelength. So what about from here to here? That's a what?
a wavelength.
Wavelength.
Yeah, that is a wavelength. So what about from here to, let's say, here?
Huh?
No,
A wavelength.
no, it's 3/4, because you have a quarter here, and the next quarter here. Right, remember, from here to here is a half. Right, so half of a half is a
whole.
quarter.
Half of a half is a whole one.
Right, so half of a half is a quarter. Right, so let's go back and see if we could find the points that are in phase. So we know that if we look, A and F is in phase because there's a wavelength. You see that? So A and F is in phase. In phase. Right, so A and F. B and D are out of phase because they are exactly a half a wavelength apart.
Yeah.
See that? Good.
Yes,
So B and D is out of phase. So I'll just say it rather than me writing it. E and H are out of phase as well because E and H are exactly a half a wavelength, right? See
Yes,
that?
sir.
And C and E are also out of phase. So B and G are in phase. D and I are in phase. Right? So those are the things you're looking for, the wavelengths. Right? Now, what about A and E? Now, A and E are not completely out of phase because it's more than a half a wavelength apart. Right? They are not in phase, but they are not completely out of phase. You understand?
Yes, sir.
All right. So wavelength. So in phase mean in phase. Right. So that would mean that we have multiples of lambda, where n is equal to, or L is n could be an element of the set 1, 2, 3, 4, and so on. Right? So if you have one wavelength, two wavelengths, three wavelengths, any integer multiple of a wavelength, then your points are in phase. Out of phase, we could get, well, of course, a point could be in phase with itself, right? So I forget to put in 0, so I could just union 0 there. All right, so out of phase, we want odd numbers over 2. And remember, an odd number could be written as 2n plus 1, and we divided that by 2. So let's talk through this. How I know that every odd number could be written as 2n plus 1? Well, would you agree that an odd number is always next to an even number? Like 3 is next to 2, 5 is next to 4, and so on?
Yes, sir.
Right? And notice that 2n is always even. Because if n is 1, 2 by 1 is how much? It's 2. Then add 1 is 3. 2 by any number. So let's take a random number. Let's say 40. 2 by 40 is 80 plus 1 is 81, which is odd. So this would actually work. This is an odd number over an even number. Well, odd number over 2. So once you have an odd number, a half a wavelength, three halves wavelength, 5 halves wavelength, and so on, you will get an out of phase points, right? So we have n here could be 0, 1, 2, 3, so on. Notice that n cannot take any like decimal numbers. It have to be whole numbers, right? Cool. So this is we define wavelength, we define phase, right? So now we want to define periodicity or period, the period of a wave, right? So period. All right, so the wave's period, or the wave is the time for one complete vibration. Right, so for one complete vibration. Now, we could have also said for one complete wavelength, right? For one complete wavelength. So, for example, right, anybody know about the sine function, as in like sine theta?
Yes, sir.
Right.
Yes,
So
sir.
this is the graph for sine theta, right? Where theta, now we know that is how much degrees we could go up to, like we could go up to infinitely many, but for a complete cycle is 360 degrees.
Yes, sir.
Right.
Yes, sir.
But we are adults now. We are in a higher form, so we don't use degrees anymore, right? Well, we do, but we prefer to use what we call radians. Now, for the sake of this level, we're not going to use it today, but in the future we would be seeing it, right? When we get to understand the topic a little bit more. But for now, we would be using degrees, but as we progress, we will start to use radians rather than degrees. All right, so theta is between 360 and 0. Now, ninety degrees, this here is 180, this here is 270, this here is 360. All right, so if you look at this wave, right, what is the period of this wave? This is the sine wave. What is the period of this wave? What is the time it takes? So this is time here. What is the time it takes for one complete oscillation or one complete vibration? Anybody? Or anyone? All right, so where the one complete wavelength is from this point to which point? It's from this point to which point? Yeah,
360.
the 360, right? So then this is the one wavelength here. So is it time to go from 0 to that level, to go from that point to that point, if this is the time axis?
360.
360, right? Yeah, 360. So the period for a sine wave is 360 degrees, right? So 360 is the period. All right, so let's say that this was time in seconds. So we will say 360 seconds. All right, what about a cosine wave? A cosine wave is similar, but it is shifted 90 degrees. All right, it is shifted 90 degrees. All right, so how do we do that shift? Well, if sine was at 0, it will now be at 1. So it will kind of look like this. So this is right here. This is the sine wave. This one here is the cosine wave. I'm just gonna draw that a little better. All right, so that's what the cosine wave will look like. All right, so this is 0. This here is 90. This here is 180. This is 270, and this here is 360. Right. So what is the period of this wave? Was it from this point to which point is our complete wavelength? From this point to which point?
The 360.
To the 360, right? So that would mean that the period for this wave is how much? If this was time in seconds.
360.
360.
Yeah, it would be 360 as well. Right? Now, these are the simplest types of waves, cosine waves and sine waves. But it also has other types of like combination. Like if I add sine and cosine together, I will also get another wave. Right? So, but for now, we just want to get the idea. So that is how we just find the period for the one complete wavelength wave. Right, so these are 360 degrees periodic. Okay, so now I want to define what a frequency is. What is the frequency? Right, so the frequency is the number of complete, so the wave frequency is the number of complete vibrations, right? Now we have a nice formula for the frequency and the as a frequency and period relationship. The frequency is equal to 1. That's to use a common F to denote frequency. The frequency is 1 over your period, or your period is equal to 1 over the frequency. Now, what is the unit of measurement for the frequency? Right, so we remember we use base units or SI units in this class, right? So where's the unit for the period?
Seconds.
Seconds, yeah. TD unit is seconds, T is in seconds. And the frequency would be in what? Well, if it's 1 over seconds, that is per second, right? But we define that to be 1 hertz, right? And we define hertz like that, you'd see. Right, so per second or hertz, that would work. Good. Now, let's do a question. I see they give us a question here. All right, and for our asynchronous class tomorrow, I would do a pre-recording and we would take a look at some questions surrounding what we did so far, such as the wave parameters and whatnot. All right, so let's look at this question. So this is time in milliseconds they give us. This here is displacement. All right, and they have a wave like this thing. Let's draw it a little better. All right, something like that. And they have, this is 0, this point here is 100, this point here is 200, and this point here is 300. What is the period of this wave? No, look at it properly. So is the distance between consecutive points. So what is the time between those 2 points? Remember, that's a wavelength. It's one complete wavelength. Is how much?
In between it is 100.
So that'll be 200, right? Because it's 200 milliseconds. It's stopping at here. Just like similarly, if I did this, if it was between the point consecutive with this one or in phase with this one, will be this 300 here. All right. So the distance or the time between these two points will be 300 minus 100, which is 200. Right? Or from this point to 200, this would be 200 minus 0, right? Which is exactly 200. Right? Now we got that the period is 200 milliseconds. Right? So, but we don't want it in milliseconds. What we want it in? We want it in seconds, right? So how do I convert milliseconds to seconds?
You have to divide by 1,000.
Divide by 1,000. Very good. Because remember, milli is by 10 to the minus 3, right? So this is like 200 by 10 to the minus 3 seconds. And 10 to the minus 3 means you're divided by 1,000. So we have 0.2 seconds. And that is a period, right? So every 0.2 seconds, the wave will repeat itself. Okay? And the frequency, what will be the frequency? It will be 1 over the period, which is equal to 1 over what?
1 over 0.2.
1 over 0.2, which is equal to how much?
5 hertz.
Right, so 5 hertz. Right, so 5 hertz. So that means 5 waves are passing every second. right? That is what the frequency means. So for every 5 seconds that pass, 5 of these waves pass, right? Because one wave is moving every one complete wave happens every 0.2 seconds, right? And that concludes this class. Do we have any questions before we close off?
No.
No, sir.
All right, so tune in tomorrow at it is 1 to 2 for our asynchronous class, which will be a pre-recording with examples done on what we did so far. All right,
Okay.
so that is it.
Okay.